Vertical datums are typically measured above the geoid. They're also measured along equipotential surfaces or surfaces of the same pull of gravity at a right angle. So the geoid is one example of such an equipotential surface, and we can see in this example here that the line along which we measure height is perpendicular to the geoid and then perpendicular to all of these dashed lines here, which are equipotential surfaces. The vertical datum is established, and then we can measure different changes in elevation from there. This is a way that we can measure vertical changes in elevation from surveying, in which the surveyor here would measure an angular distance between this point and this point, and then using the distance along the ground be able to calculate the vertical difference between these two as this vertical difference here. The vertical datum of 0 is a datum, but it's not necessarily sea level. We're able to measure sea level in a lot of different ways. This one shows an example from Puget Sound in Seattle, Washington, and we can see that we have a mean high water of 10.49 feet, a mean low water of 2.83 feet, and then a mean sea level of 6.64 feet. So according to the vertical datum, the sea level in this area would actually be 6.64 feet above the North American datum. And the North American datum 0 value is in Canada, in central Canada, and that represents the one place where the vertical datum for the North American datum happens to be the same as mean sea level. So once again, if you were surveying up from sea level, that could be your 0, but if you want your numbers to match the North American vertical datum, you would need to understand how this relationship takes place.